Hey everybody, Mr. Reeves with you yet again. And today we're looking at finding missing values in order to create equivalent expressions. So in our previous lesson, we had an introduction to not equivalent expressions. I misspoke. Equivalent ratios is what we're talking about. We'll talk about equivalent expressions later on. But we're talking about equivalent ratios. Equivalent ratios are two ratios that, when simplified, will simplify down to the same value. They are of equal value. If you take the first number and divide it by the second number, you will get the same answer. Now, when we looked at equivalent ratios previously, we made a list and it made it kind of easier to see how they work. So I'm going to start with number one right here. 7 to 3 equals something to 12. All right, so let's just say we started with the ratio of 7 to 3. Remember we talked about those diagrams. If let's say that was the first row in a diagram, then the second row would be to multiply those by 2. So if I took both of those and I multiplied them by 2, the result would be 14 to 6, right? And then if I took that original one instead and I multiplied it by 3, or if we were picturing it as a diagram, I was looking at the third row. Well, now I'd have 7 plus 7 is 14. 14 plus 7 is 21, right? 3 plus 3 is 6. 6 plus 3 is 9, right? And if I did it again, now we're to the fourth row, or multiplying the original one by 4, we would get to, let's see here, 7, 14, 21, 28, and 3, 6, 9, 12. And you could see, hey, there we go, right? Because we were looking for 12, and there we have 12. And so the answer to this problem would be 28. 7 to 3 as a ratio is equivalent to 28 to 12. All right? All right, and we could do that. There's absolutely nothing wrong with that method. Just start with the smaller one, right? So in this case, we would start with 7 to 2 and work our way up to 12. Or in this case, we'd start to 6 to 7. So if you always start with the smaller ratio and work your way up to the bigger ratio, you can just keep doing it that way. But it's not really a practical way to do it. There's got to be a better way, a faster way, a more efficient way to get that done. And of course, there is, because this is mathematics, and that's one of the whole points of mathematics, is not only solving problems, but finding the quickest way possible to solve problems. All right, so let's take a look. Let's do this one again. So this is what we don't know, right? This is the one we don't know. So let's focus on what we do know. We're going to start with the smaller number, and we notice the smaller number is 3, and the larger number is 12. All right. So when you're doing these problems, the first thing you want to check is the larger number divisible by the smaller number? If it is, then we can divide. All right, so we're going to take the larger number, which is 12, and we're going to divide it by the smaller number, which is 3. So what we're saying is, how many of these 3s, or how many groups of 3s are there in 12? And the answer is 4. All right, so that tells us that this second ratio is 4 times the value. The first number and the second number are 4 times the value of the original one. Now, they actually are equivalent, which means they have the same value together, right? But we need to take both the first one and the second one and multiply by 4. So since 3 times 4 is 12, I'm going to do 7 times 4 to get that answer. And again, that answer now we know is 28, right? 7 times 4 is 28, and 3 times 4 is 12. Again, I don't want to confuse you. That doesn't mean that this second ratio is 4 times as big, all right? If, again, we can write ratios as a fraction. If I write 7 over 3 and 28 over 12, they are actually equal. Because we made both the numerator and the denominator 4 times as big, they are actually equal or equivalent. Okay, this is not 4 times bigger. The numerator is 4 times bigger, the denominator is 4 times bigger, which means that as a fraction, it is equivalent. That's the word we're looking for. Remember, equivalent means equal in value. That's what equivalent means. It may look different, but it is equal in value. All right, so the answer to this first one was 28. All right, so I'm going to go ahead and take a look. Again, this is the one we don't know. Let's focus on the one we do know. All right, we know the second number is 12, and the second number on this one is 2. So again, I'm going to take the larger, and I'm going to divide by the smaller, and that's going to tell me that multiplication factor. So I'm going to take 12, and I'm going to divide it by 2. 12 divided by 2 is 6. That tells me that that number is 6 times bigger. So if the second number is 6 times bigger, what does that mean? That means the first number needs to be 6 times as bigger as well. And what is 7 times 6? 7 times 6 is 42. So the answer we're looking for on that second one is 42. So if we look at both values of the first ratio, both values are 6 times bigger. Therefore, they are equivalent, okay? Same thing on this next one. Take a look at the two that we know. We know 36 and we know 6. So I'm going to take 36 and divide it by 6, and what do I get? I get 6. That tells me that 36 is 6 times as big, right? So what does that mean? If the first number is 6 times as big, then the second number needs to be 6 times as big. And what do we get? 7 times 6 is still 42. What about this one? Okay, I know 1 and 7, so if I do 7 divided by 1, I get 7. So that means that the first number is 7 times as big, which means what? The second number must also be 7 times as big. 4 times 7 is 28. All right. Now, just so you know, for this worksheet, they will always go in evenly. There are times where they will not go in evenly, in which case you will need to simplify, or sometimes you're just going to get a decimal answer. But the good news is, on this worksheet that I gave you, they will always divide evenly. So find the two that you know. I know 99 and I know 11. Take the larger, divide it by the smaller, and that will tell you what you have to multiply by, right? 11 times 9 is 99, so I'm going to do 12 times 9, and 12 times 9 is 108. Take the larger and divide it by the smaller. 40 divided by 5 is 8. That tells me that I have to multiply the first number by 8, and therefore I multiply the second number by 8. Do you see how that works? That's what's true about equivalent ratios. Both the first number and the second number are multiples of the same number. If you're going from the smaller to the bigger. If you're going from the bigger to the smaller, they are quotients of the same number. But I'm just encouraging you always to go from the bigger to the smaller. So I'm going to take 35 and I'm going to divide it by 7, right? And that gives me 35 divided by 7 is 5. So I know that I multiplied the second number times 5. So I'm going to multiply the first number times 5. And I get 5 over 35. All right, so that's how you do these problems. Again, take the larger, divide by the smaller, and that gives you your factor. That tells you what you are going to multiply by. All right, I hope this video was helpful for you. If you need more help, by the way, I just want to encourage you, make sure you also watch the Khan Academy videos and do the Khan Academy practice. All right, have a great day, and I'll see you next time. Bye.